So today I want to talk to you about phase shift. That sounds really crazy and science fiction-y. So what am I talking about? If you have paid attention to what we've been doing with graphing the sine and cosine function, you'll have noticed that we have shifted it, translated it up and down. That's when we moved the midline up and down. And we moved it up and down by adding outside of the sine and cosine function. We stretched it. We did a vertical stretch when we made the amplitude larger or smaller. We did take and we changed the period. So we actually squished it sideways. We could make the period shorter or we could make the period longer. One thing that we haven't done is we haven't flipped it, and we haven't translated it to the left and to the right. So that's kind of what I want to talk about today. Phase shift in particular is talking about shifting it to the left and to the right. So if you recall, we talked about that the only difference between sine and cosine is that sine starts on the midline and goes through the cycle up, back to the middle, down, back to the middle. And that cosine starts at the top of the wave, comes down, goes to the lowest part, comes up, and then ends at the highest part. But what if it didn't start there? You have to remember, on the circle, the reason that they started in the positions that they did was that we always start spinning on the circle over here at the x-axis. This is the point 1, 0. At this point, cosine is 1, so it starts at the maximum, and sine is 0, so it starts at 0 and not in the positives or the negatives. And then we rotate going counterclockwise. But what if we didn't start here? What if we started somewhere else on the circle? If you think about real life situations and real things that spin, they don't all start right here. In fact, if we just think about a very simple, the Ferris wheel, if you've ever ridden a Ferris wheel at the state fair, you don't normally load the Ferris wheel here. In fact, generally we load the Ferris wheel down here at the bottom, and this is where people get on and then they rotate around the Ferris wheel. And so what happens if we want to have the Ferris wheel start here instead of starting over here? We're having to shift around the circle. And the way we do that, for example, if instead of starting here, I wanted to start here, I have to think about, well, how many degrees different is that? In this case, if I think about the circle, instead of starting here, if I'm starting down here, I could either say that I wanted to move it negative 90 degrees, or I could say that I'm going all the way around 270 degrees. You could think about that either way. But what we're saying is that instead of starting at 0, I want it to start at negative 90. Well, the problem is that's not how sine and cosine work. For the sine and cosine model, I need this initial starting point to be 0, so I'm actually just going to add 90 to both sides. So that would mean that x plus 90 would be where 0 is happening for this particular model. And so that is why, if you recall, left and right translations always happen inside the function, and they always seem to be backwards. And it's because of this concept of we have to make it equal to 0. So even though I was trying to shift negative degrees around the circle to start over here, when I look at my equation, that would actually be sine of x plus 90 degrees. This would make my circle, instead of starting here, start here. So if we think about what that does to the actual graph, instead of sine starting at 0 here in the middle, it's actually at time 0, it's down here at the bottom of the loop. And what that means about our actual graph is that my start, instead of starting here at the front, it has shifted over here to the left 90 degrees. And so it's going through some stuff before it gets to 0. And then it continues on and on and on and on. So let's look at a graph and see what that looks like. So let's take a look at the example y is equal to sine of x minus 60. All right, so this means that I did not add anything outside of the function. Notice this is in parentheses with the x, so that means it's happening before we take the sine of it. So that is inside the function. If nothing is added to the outside of the function, then we know that our midline is still going to be at 0. So we have that middle line here. We know it is sine, so wherever we start, it's going to have to be on the midline. The amplitude is 1, so we're going to go 1 above and 1 below. And it's not being multiplied. There's no angular speed written here, so it's the understood 1. So we know that our period is going to be a full 360. I do notice that my graph is counting in degrees and not radians. So it's going to be 360 for a period. So what I do notice, though, is that it subtracted 60 degrees. So instead of me starting here on 0, that means that it's subtracting. So I'm going to shift to the right 60 degrees. Again, if we're thinking about it on the circle, instead of starting over here, I'm going up to 60. And so I'm starting my ride around the circle up here at 60 degrees. Now, that means 60 degrees is here. So this is actually where I'm going to start my sine wave. Now, I know that it has to have a period of 360. So 360 plus 60 is 420. So here is one full period, start and stop. And I want to break that into half. I'm going to put it in half. 180 would put this at 240. So here's the halfway point. And then 1, 2, 3, 4, 5, 6. So half of that would be here at 3 and here again. So again, I just found my starting point. It was on the midline because it's sine. I moved it over to 60 degrees because we had subtracted 60. So that moved it to the right 60. I plotted out one whole piece, and then I cut that piece into 4 equal pieces, because no matter where these 4 dots are, I draw my sine the exact same way. I know that sine starts in the middle. By the first quarter, it's up to the top of the amplitude, back to the middle, down to the bottom of the amplitude, and back to the middle. So that gives us this sine wave. Now, in general, we do want them to start over here. So I did notice my pattern. It's 3 every time. So 3 of these little lines. So it's going to go back over here to get under. And over here, it would be back up. So I just complete it for the whole thing. But I do get this ongoing wave. But it moved over. It started over here instead of starting on the x-axis. The other transformation that we want to remember is flipping. So we mentioned that sine always starts on the midline. So it goes up, back down, and back to the middle. Cosine always started at the maximum would go down and then back up to the top. And that was the difference between the sine and the cosine wave. But just like all functions, if we multiply it by -1 outside of the function, it's going to flip that upside down. So my sine wave, instead of going up first, if it's negative sine would go down, then back up. So down, back to the middle, and up, and back to the middle. That would be negative sine x. If I wanted to do negative cosine, well, cosine normally starts at its maximum, but if I'm going to do the flip of it, that means it's going to start at its minimum. So it's going to start at the bottom when it's negative. And then again, when we go through, it would be back to the middle, up to its maximum, down to the middle, and back to its end. So you've got the same shape, the same amplitude, the same shift rules and everything. It's just that if it is negative, then you go down first for sine instead of up first, and you start at the bottom for cosine and go up instead of starting at the top and go down.